Hello and welcome. Thanks for coming and joining me in my shop here today. It's November 8th and we're about to start on this great big radio here. This is an RCA Victor A38. So just looking at it on the face of it, it's pretty good shape. It's got all its knobs. Still has its original cover over the speaker, the grill cloth. Glass is good. I can see the magic eye in the middle of the glass. It's got push buttons. All the buttons are there. There's no really big time damage to the cabinet. It's certainly worn on the top, but other than that, these cabinets are very rugged. So let's take a little closer look at it here. Oh, we can start with a close-up of the decal on the front there. RCA Victor Globetrotter. So Globetrotter is a pretty common name for various radios. And if you look just over here at the knob, you see the band is indicated inside the circle there. So as you change bands, band B, 31 meter band, 25, 19, and this is a broader band, 16 to 13 meter bands involved there. There we go. That's gotten a little marked up, but not too bad. Okay, the other controls. This is the tuning control. Let's just see what happens when we tune the radio. See the pointer inside. Okay, string must be intact for that to work. Down here, so these knobs are rubbing on the cabinet here. There's the on-off switch. This is probably the tone control, but I'm not absolutely sure right now. So we'll take a look at the glass here, which is really quite fantastic. It's one of the reasons I really like these radios. You can see the band spread. If you look at the 19 meter band here, you can see it's starting just above 15 megahertz. You gotta go all the way over to the far side. And what's happening there in front of the 13 from here? There's something on the glass here, some kind of paint or something like that. Very hard for me to show you this. Maybe if I come down from above. There's all the reflections in my shop. Yeah, it looks like something got spilled on the front of it here. And I noticed earlier there's some red paint dripped on it also. So these complicated glass ones, they have markings on the front of the glass, like this green. All this green is on the front here. You can scrape it off if you really worked at it. And much of the rest of the print is in behind. So these are pretty rugged. I don't find these worn out very much. He put some really good paint on it. What's cool about them is they list different cities and that. What can we read there? Philadelphia, Schenectady, London, Schenectady, must have been an important place back then. Onward, Wichita, Boston, a lot of American locations. New York, London, Berlin, Mexico. So they go from a city to a whole country there. Of course, these aren't accurate anymore. You won't find those countries at those locations, and many of those countries aren't even broadcasting on shortwave, but others are. So this set comes with a push button presets. Not sure what that one is. CBL, that's CBC. I don't know L. CBL. I think that was Toronto. WJR, that's Buffalo, I think. CFRB, that's St. Catharines. The label's missing here. This first button may be for switching on like a phono input, I'm not sure. The buttons are a little sticky, of course. A little loose in the radio. So just looking at the cabinet here, I have the camera just a little out of focus. Pretty rough on the top. The wood itself is intact, so you could refinish this and make it look great. And kind of odd things that have happened to this cabinet. That looks like something a kid would do. Okay, just looking around here, you know, this all just needs a good cleaning. This is a little rough here, probably from hands being on it when the radio was used. But there's no serious cracking in here or anything of that sort. A blob of green paint. Okay, just looking at the knobs a little closer, they're in great shape. These are good knobs. These big ones are very good knobs. Okay, let's take a look down here. So you can't expect the grill cloth to last forever. You know, as grill cloths go, it's not too bad. A little punched in. Feels like cardboard behind here. The side's been pulled a little bit. But again, it's not terrible. The kickboard at the bottom, that's actually not so badly damaged either. And what you can do with this lower part, especially this lower part, that could be repainted down here. Not bad. Not too bad. Okay, we got to take a look in the back now and see what's happening back there. Okay, let's get into the meat of it here. So, now the owner told me he bought this very recently. He plugged it in. It made some sounds of some sort. And that's about it. Okay, I'll start with the antenna here. So this has an attractive feature in this steerable antenna. Let's read what it says here. This is the RCA Magic Loop Antenna, high efficiency, developed for finer reception. So what this really did was this helped sell radios, of course. This works only on the AM band, and the idea is, without this, you're going to try a long piece of wire out your backyard. That's a hassle for locating the radio. And those wires, for AM radio, they don't work really all that well. They can't compete with a coil loop like this. It's steerable because the radio is going to go where it's going to go in a person's house. And if the antenna is fixed in place in the radio, then that's it for the direction. It's wherever the radio goes, that's the direction. That can be very detrimental. These antennas have a very deep null, which means they have a dead area. You can aim them at something and make it disappear. It's not so much that they peak up a signal, it's that they can null out things that you don't want to hear. They do also peak up a signal, but so typically you put your radio in place, you tune in the station you like listening to most, you reach around the back here and turn this guy to get the best reception, and then you just leave it. That's the end of that. There's the odd radio where you can turn these from the front. They have a dial on the front. but not this one. So this piece of wire, with all the insulation that's coming off of it here, this is typical of wires that have had very flexible insulation at one time when they were new, but the very thing that makes them flexible when they're new makes them go like this when they're old. They just get very, very stiff, crack, and come apart. This is the external antenna, which appears to be soldered here. And this wire may well have run around the inside of the cabinet at one time, and someone's pulled it off, and that's why it's out here now. We don't want a big chunk of bare wire floating around working on this thing. This really is of no advantage right now. So this would attempt to boost the signal on the loop antenna, but it's not very effective. For the shortwave, there's terminals on the back of the chassis for hooking up the shortwave antenna. That's kind of where this maybe should have been. Don't know for sure. Just going to get it out of here. There's a crummy piece of wire now. Okay. Now this antenna, because it's mobile like this, is often connected with a set of flexible wires which have gone just like that last wire I just showed you. Let's just take a look here and see what the story is. So these well, it's a little tricky to see. I'm going to rearrange the camera here a little bit. But sure enough, those wires have gone the same way. Insulation is broken off of them, and they're shorting out. So I mean, you can't have those wires shorting out to the antenna. The result is going to be bad. So you can see them right there. There we are. So you can see the bare wire right here. These aren't terrible. They go into a plug right here. Okay, we're just going to leave that out for now. And now we're up looking at the actual radio. Okay, let me just untangle a bunch of wires back here. I'm just going to put this light down. So my problem here in shooting this video is my screens are behind me, so I can't see easily what it is you're seeing. Okay, well, we'll start right in this area. So this radio has a index on the back of the main tuning dial, and that's because when you draw the cabinet, the chassis out, you're going to leave the glass behind. So at that point, you don't know what the pointer's pointing at. So they have this index on the back in a way of using that index to tell what frequency you have the radio tuned to. So when you're doing bench work, you can get away with it. It's a 3-section capacitor. It's 3 tuned sections in the radio, 3 tuned stages. That's very good. Two tuned stages and 1 local oscillator. There's a magic eye sitting here. Up here, you can see this is the back of the push buttons, and this is how the buttons are adjusted by tuning these capacitors, and most importantly these slugs here in the coils. So it's not, you don't pull the button out and push it in like a car radio. You have to come around the back and spend some time tuning these. It's not so easy. You have a light bulb here and another one on the other side. If those lights are set right, they cast strong light right into the edge of the glass plate at the front of the radio. And it makes all the numbers in that really pop nicely. If those lights are not positioned right, then you get not nearly as nice a presentation. So as small a deal as you might think it is, it's actually a big deal. The radio is sitting on a sheet of asbestos. You can see it right here. I can see bits and pieces of it here and there. There's quite a bit piled up right over in here. So we're going to want to do something about that, I think. Options are just leave it alone, or remove it, bag it, and throw it out. In terms of this being dangerous, I mean, if you were to take it and do all this kind of stuff, snort it in for a day or two, and if you were young enough, maybe. But I think people who get sick from asbestos are exposed to it industrially, normally. So, but you still want to handle this properly. You don't want to have the asbestos particles come off here and then end up in your shop, your house, or wherever. I mean, the idea would it be best to have this outdoors when I take it out. Plus, when you're gonna take the chassis out, you drag it across the asbestos. You're going to tear it a bit, and it's going to end up in worse shape. Most of the alignment of the radio is done right in here with these adjustments. Not all of it. There's some other adjustments here and there. These are the oscillators, I believe, so you can get at them with the radio in place. So at the very end of the process, if you want, you can go through the oscillators again and get the dial pointer really, really accurate. There's two big IF cans. Somebody has spent time trying to solder this here. And this one's still soldered solid. This one, so this would definitely disturb the radio a bit if this is making incidental or intermittent contact here. It's got its tubes, as far as I can see. They're all in here. That's the output tube. Is a 6K6. Okay, but we'll be checking to see if these are the correct tubes. Just some chance they may not be. Power transformer there. It's a metal clad capacitor that's loose, wiggly loose. It's probably been replaced. Wiggly loose, wiggly loose. See, the capacitor is mounted on rubber mounts. The rubber mounts look pretty good. That's good. Now, for the interesting part. Let's take a look at the interesting part here. So these big old radios, they have field coil speakers. That's not a field coil speaker. That's a big whopping magnet here. You can see the wires coming over to the voice coil. And lo and behold, the output transformer sitting here. So this is the original plug that would go into the speaker with its field coil. And it would look to me like somebody's just shoved the wires in. Two of them heading to the output transformer. And two of them heading down. Quite a contraption here. This is ordinary lamp cord. This is, I don't know what this is. Car hookup wire, I don't know what that is. And down below is the remnants of the original speaker. This is the back part of the original speaker. They ripped it all apart to do this. And that's to maintain this coil here. This I don't know what these are. I'm going to guess this is part of a humbucking coil. Not connected anymore. So of course he's maintaining the field coil. So the power supply in the radio has the field coil operating, because it requires a field coil to as main part of its hum filter in a power supply. that's quite the speaker there. That certainly is comparable. It's a big, it's actually it's a big one. That's important in here. Chances are this sounds great, but maybe not. Maybe, I don't know. Maybe this doesn't really go with this output transformer. I don't know. Somebody knew what they were doing when they did this, so it kind of leaves me wondering what else might be going on in this radio that somebody may have done. Looks pretty normal. So I'm going to get this out and get it up on my bench, and we're going to look underneath it, see what it looks like underneath. Maybe it's already been restored. Maybe it's just like new under there. So on these radios, there's a number of things that need to be unplugged. One is the speaker, which I unplugged from below. But another one are these push buttons, which have 3 wires coming up on this side into these kind of terminations. I took a photograph of this so I can get these back in the right order, because it's not obvious how they fit in there. And then there's a cable coming out the other side, which unplugs. And now the chassis is free to come out. Let's see. I've taken the knobs off already, of course. There we go. There it comes. There we go. Okay, we can take a little closer look at this now. When I took the knobs off, I discovered this knob is actually broken away here. Someone's tried to fix it up with a little bit of cardboard. Boy, it was a little bit floppy now. You don't actually turn this knob. It sits in one spot, and the knob with the hole is rotating over it. Okay, but it has to come off if you're going to get the chassis out. So you can't fix it in there permanently. So let's see what we can find out about this radio now. Serial number looks like 375, not sure. Watts 80. A38, I'm pretty sure that's what that says. Very good. Montreal, Canada. Made in Montreal. Okay, we'll come around. See the magic eye a little better now. Not too much to see. That knob I was talking about fits on the sleeve here, like this. And it just sits there. It doesn't turn. So as long as it'll sit there, you're good. Okay. So fair bit of dirt up in here, where it was difficult to get your hand up into and to even see with this in the back of the radio. Someone has, excuse me, dusted this off a few times perhaps. Somehow, maybe they vacuumed it a little bit. They couldn't get way up in the top here on the magic eye, which is quite dirty. So this guy's he's been somewhere dusty and dirty for quite a while. Okay, let's take a look at what's underneath. Now, how can I tip this up? It has these lights sticking out the sides. You can tip it backwards, it'll be resting on these cans. It's going to probably break the solder here. If I do it like that, these are spot welded on. I can't get rid of these little brackets. I can flip it right upside down. I'm going to be riding on this, which is quite strong, but sitting on top of these, which is not the best idea. Okay, so I could block this. I could put a block across here. Maybe this is what I'm going to do. Not quite high enough. That's my only long block. Oh, that'll do. before I could actually put it on here. It's a little harder to flip it over and make that happen. Flipping it over is difficult. Like, this is a big heavy guy. Don't want to be banging it around too much. There we are. That's pretty good. I like that. You're just going to have to stand up a little taller. Okay, well, despite the fact that somebody has worked hard on the speaker, nothing has been done under here. This is completely original. And already catching my eye is the shell on this capacitor is all cracked. You can see metal right through the cracks. Yeah, and then we have all these very old capacitors over here. Hey, what's that? That's not very old. So somebody has done some work. Hey, what's going on with this one? It's floating in space here. So these are the kinds of things that make me nervous. Why would that be left floating up there? Any other weird things going on? So the power cord is in bad shape right here. This power cord is no good. Might as well just get rid of it. Might be able to shorten it up actually. So it may be fairly good in the rest of it. But let's get this part out of here anyway. Now most of the wires in a radio like this have become, at this point, have become extremely stiff. And if you bend them, chances are the insulation will just crack away. Oh, look at the asbestos right here. I didn't notice that. Yikes. Gonna have to deal with that right away, I think. Okay, no power cord. But I could feed power into here. It might be a very convenient way of doing it. So this is the bottom of the big power transformer. You can see the wires coming out. That's surprisingly flexible there. So they're not rock solid, but they're pretty close. So can't be bending any of these anywhere. This one that's coming out is this must be the center tap of the high voltage. It's going right to the chassis here. Okay, I'm going to grab a close-up camera and we're going to go through this with a very close look. So what I'm doing with the asbestos is I sprayed some WD-40 onto it. It just about disappears from view. And I'm just wiping it up to get rid of it as much as possible. Of course, you want to soak it with something so the fibers won't fly around. So get up most of the loose stuff. There's some fibers around the edge here, which I've removed the same way, basically. I'm sure there's still fiber on there. That's going to take a little while to get done. So I'm going to work away on getting rid of it all. Okay, so I've got that all cleaned up, and I also removed the asbestos sheet from in the radio. There it is there. And I'm going to take this outside, tie it up, and dispose of it in the regular household garbage. That's where it should go. But it needs to be inside a bag, if you want to try to follow the rules. That's my understanding of it. Okay, let's take a close look at it now. We'll just start in one corner and kind of work our way through. I'm just looking for things that aren't normal, or like this capacitor that's disconnected. It's a pretty modern one, just tacked on the end of a wire. Pretty clear where it once went. Anyway, why it's like this, who knows? And down here is this replacement. 1.5 thousand horsepower. Wow, that's quite the capacitor. Right behind it is this sick old puppy sitting here. So this one looks like it was from maybe 20 years ago, something like that. Hard to say looking at that, but maybe 20 years ago the work was done in here. The speaker was fiddled with. But not all these tired old, these are really bad capacitors. Okay, trying to spot any resistors. There's another black molded capacitor. It could be okay, but it could not be okay. But these ones are, look at the cigar guy here, he's got to go. Some old resistors too, they've probably gone high, but you don't know how much they've gone high. There's a big one here. Looks like a plus sign on one side. Well, I don't know, maybe that's electrolytic, maybe not. Another big one. Now see, in these radios, sometimes the part number is just the company's part number, and it doesn't tell you much about the value. That's first. You know what? This probably is the value. 0.1 microfarads, 400 volts. Don't know what the 3F would be. Okay, so here's two old guys here. Now the black one is not reliable. See the crack in the seam? Well, it looks like a crack anyway. Pretty sure it's cracked. That's going to let moisture go in. Not that these things are perfectly sealed ever anyway, but this reddish one looks great. These are much more reliable. I would not run out and change these offhand. Not that type, but these black ones, there's quite a few of them. Some hard to get to. Hard to get to, guys. Oh, look at them all jammed down in here. Lots of these. You have to kind of weigh up the benefits of doing it with the risk of trying to do these parts, because they could be good. The capacitance has a lot to do with just the physical placement of the materials inside, and they don't move. Obviously, the dielectric can have changed over time. No, that doesn't look like an original capacitor there. Is it? Made in USA. I don't know. Oh, that looks like a cold solder joint down at the bottom there. That could be a replacement. Just doesn't, just looks way newer than all these other ones. Look at way down in there. Man, that's tough. That's tough to try to replace that. Resistor, that white one looks like a capacitor too. Be a special one in some way. Ceramic is what the word is on there. It could be possible that it's temperature compensating capacitor. It may not be something you want to just jump in and change, because it could be working fine. Yeah, capacitors can be in critical circuits where a slight degradation of the capacitor is a big deal, and in other cases, no. Now this one really had the biscuit in terms of the, this is the first one I saw right away. Why is this guy all cracked, but the guy right beside him not cracked? Hard to say. It might even have to do with the day they made the compound, that they, this black material, when they mixed it up in the capacitor factory. And the guy wasn't paying attention. I wouldn't jump at these, changing them. I mean, this one maybe, but even that one, it could still be valid. The earlier radios, the capacitors weren't covered at all. They were just right out in the open, dielectric and all. So all these coils are the tuning coils for the different bands. And I think if we just go from here and go up here, go, aha, there's all those adjustments there. And what they're actually doing is they're moving these slugs inside these coils, band by band. So I'm asking myself too, gee, should I turn this radio on? Try powering it up. Now I like to operate these things as soon as I possibly can. That's quite a busy coil there. That's probably the oscillator coil. You know, it's not shaped like that by accident. It's been wound very, very carefully to achieve exactly what the designers wanted out of that coil. Burn that coil. Goodbye radio. That's one reason why you don't want to turn it on until you are somehow reassured. And just, yeah, okay, I thought I was looking at a capacitor, but I'm not. Okay, well, it's nothing too surprising in here. Just kind of the usual. I know these paper ones have to be changed out. Again, I'm just, you know, if there was something really seriously wrong, like maybe the power transformer is fried, why would I do all this work changing all these capacitors only to find that out then? And there are a number of electrical tests that can be done. You know, you can gouge your ohm meter and ohm out all the coils and that. My own experience with that is it leaves you with too many question marks about the tests you're doing. That's the big band switch there. Looks okay, as far as you can see. A lot of these capacitors that we might be concerned about are not in a position where if they shorted, you know, some component is at risk. Some are more likely to be this type. And you can see a shielded wire here, how they've shielded it. It's a spring type deal, and as it travels along they solder it into the chassis and then back down here. So it's not grounded at this end, and it's not grounded at, yes, it is grounded. Grounded at, probably under there somewhere. Probably to that lug there. Grounded at one end, in the middle. Well, that's quite a job done there. So what else is soldered to the chassis? Lots of stuff. How about these tube sockets? Is there anything direct to the chassis from the tube socket? can't see the whole socket there. Here's one. You can see the whole socket here. I'd say no. Nothing is bent over and soldered to the chassis. About what we can see of this one. So I'm just curious about how the heaters get their power. Some radios use the chassis. Very good. Well, it's not very good, but it's okay. And so here's a capacitor you adjust from above. Should be a couple more of those. Usually there's a couple more. Here's one over here. I bet you there's another one in here somewhere. So this wire has that on it. Why did they do that? Well, it's hooked up to something moving. I can actually see through the hole. Let's look underneath. I'm just blindly moving the camera around here, wiggling the wire. Okay, that's not working so well. It's probably, I've got it now. It's one of those 3 wires that go up to the push buttons, and that's just a strain relief method they've used there. Oh my gosh, so these capacitors could be like their physical position can be significant. That one almost looks like it's shorted on the no, it's not. Of course it's not. I was in the middle of saying something and then got distracted, but oh, that happens often. Okay, I think we've seen all we need to see. Here's some more adjustments that are made from the side of chassis here. They look pretty rusty screws in there. Looks nice on the top, but the seam is split on it. Shouldn't probably be too hesitant to change these ones that are easy to access and replace. Shouldn't be too hesitant about them. But at this point, we have no reason to do that. We have a reason to do this prior to turning on the set. But I have ways of powering up the set where I can control how much power goes into it. Talking about power, look at this. So it's not really risky for me to start it up if I really choose to. The trick is I have to get the speaker and the field coil and all that stuff somehow connected up. That's a bit of a hassle. And a big resistor there, but it looks to be in good shape. Big resistors generally run a little warm. That's why they're big. But it looks okay. This is the filter capacitor, the bottom of it. There it is there. How is it done? So you can see some solder to the chassis. So what they've done is they pop it in, and these little tangs come through slots, and then they twist those tangs to lock down the capacitor, and then they solder one of them to the chassis. I have to study the schematic to figure out what's really going on there. There's that lone floating capacitor. Now, should I start it up with this hanging out, or would I have to figure this out before starting it up? I could probably start it up with it hanging out. The objective of starting it up early is to find out if it works, or if there's a hint of some big ugly problem, like the power transformer or like a short in a IF transformer or something like that. All unusual things that don't normally happen. Okay, well, I think that's a good look over. I have a good idea what's in store for me here with this. These radios are great performers when they're fixed up, and so I would like to get there with it for sure. So I'm going to spend my day thinking about what to do next. Try powering it up just as it is, do some replacements, and then power it up. The other thing about that is as soon as you start doing replacements, at that point you don't know when it doesn't work. Is it because it never worked, or is it because of your replacements? Did you make a mistake? All that kind of stuff. Be a big headache. So better to get it operating, even if all that happens is you touch the antenna and it changes what comes out of the speaker. That's almost all you need right there to identify or to kind of prove that it's capable of working without any major problems. Okay, that's it. So thanks a lot for watching. Tomorrow we'll either start some replacements or I'll get bold and we'll try powering it up just as it is. Maybe I'll study up on what this free capacitor floating out here is all about. And I get the schematic. I got to go through the schematic for it. We're well on our way. So thanks a lot for watching.